This video shows a working prototype of CANbids, which is an infrastructure for dependable systems based on the Controller Area Network standard. CANbids provides redundancy at several different levels to distributed embedded systems that require a high degree of dependability. The video shows the functioning of two of the main functionalities of CANbids. The first functionality is the tolerance of faults that cause network nodes to generate incorrect data. The second functionality is the tolerance of faults that affect the network. Before we show the video, let us briefly describe these two functionalities. To tolerate faults that cause nodes to generate incorrect data, node redundancy is used. That is, a given task is not performed by a single node, but by several nodes. For this, the task that is executed by each node is divided into several segments. Each segment of each node produces an intermediate result called a CC vector. A decision algorithm is then executed on each of the nodes to generate a consensus CC vector. That is, a CC vector that the nodes have agreed to be the correct one. The agreed upon consensus CC vector then serves as the input for the next segment on each node. In this way, a majority voting is performed for each intermediate result, and thus, incorrect intermediate results generated by a minority of nodes are discarded. This allows CANbids to tolerate faults that cause nodes to generate incorrect results. The other main functionality of CANbids that the upcoming demonstration will show is the tolerance of faults that affect the network. This is achieved thanks to the underlying replicated star topology that is part of the CANbids architecture. As can be seen in the diagram, the replicated star topology is comprised of two stars. Each star has a hub to which all nodes are connected. Then both hubs are interconnected by means of interlinks. This provides each node with a redundant way to communicate with the other nodes, thereby eliminating any single point of failure at the network level. Moreover, each of the hubs is able to contain errors caused by a single faulty node or link, thereby preventing a general failure of the network. The prototype shown is comprised of three nodes: Node 0, Node 1, and Node 2. Each node is initialized with an input that is basically a sequence of numbers. These numbers represent the local CC vectors generated by each one of the nodes. Once initialized, we press a button to start the execution of each node. The nodes then show on their LEDs and on the computer screen the local CC vector followed by the consensus CC vector. The system is functioning correctly as long as all active nodes reach the same consensus, which occurs as long as only a minority of nodes disagree on the current CC vector's value. To illustrate this, node 2 will suffer a temporal failure. As can be seen, the local CC vector of node 2 disagrees with the one of the other nodes. However, the consensus reached is the same for all nodes. In other words, the failure of node 2 is tolerated. This demonstrates the correct functioning of the voting mechanism in our prototype, and shows how the failure of nodes is tolerated. After node 2 recovers, the next part of the demo will show how, thanks to the star topology, CANbids is able to tolerate faults in the network itself. For this, we will inject faults manually by physically unplugging links. We start with the link that connects node 0 to hub 0. Thanks to the redundant link to the other hub, the node can still interchange its CC vectors with the other nodes. We now inject another fault, this time into the link that connects node 1 to hub 1. As before, this network fault is also tolerated. We also inject a network fault into the remaining node, specifically into the link that connects node 2 to hub 0. So far, we have been able to tolerate 3 network faults thanks to the replicated star topology provided by CANbids. We continue the demonstration by now completely unplugging node 0. This causes node 0 to no longer be able to communicate. And as a consequence, it can no longer transmit its local CC vectors to the other nodes. This means that the voting mechanism will have to continue without the participation of node 0. However, this is not a problem since still a majority of nodes are active. These remaining nodes determine that node 0 is no longer active by waiting a fixed amount of time for it to send its CC vectors. Once this amount of time has elapsed, the active nodes decide that node 0 is not going to participate in the voting of the current segment. In this way, the remaining nodes can still provide a correct service. To recapitulate, we have so far tolerated an incorrect computation of CC vectors by node 2, 3 network faults affecting individual links of each node, and the complete disconnection of one of the nodes. This demo should therefore serve to substantiate the claim that CANbids is adequate for embedded systems that require a high degree of dependability.